Okay, let's quickly run through this. So for each of these, we have a coefficient, which in this case is 3. And we have a base, which is a, which is the value that we're raising to a power. And then the exponent is x. Next one, coefficient's 5, base is 7, exponent x again. And here we have 12, b, and q. Okay, so we can demonstrate this just by writing this out, and this is sometimes a good way to remember if you're not quite keeping in mind sort of the how we do exponent multiplication when we're talking about the same base. So x to the fifth, 5x's times x to the third, 3x's is x to the eighth. Okay, similarly, we can do something like that for x to the fifth divided by x squared. These cancel out, so we end up with 5 minus 2, or x to the third. So x to the third, which is equal to x to the 5 minus 2, which is equal to x to the fifth over x squared. Okay, here we go down the table, and we're just dividing by 4 each time down. And that means when we get down here, we are getting the reciprocals of what we got up here. So each of these are reciprocals of each other. So, and it makes sense because we would say 4 to the first times 4 to the negative first would be equal to 4 to the 1 minus 1, the sum of these two exponents, which is equal to 4 to the 0, which is equal to 1. Okay, over here, 1/4 to the third is going to be 1 over 64, 1 over 16, 1 over 4, 1 over 1, and then 1/4 to the negative 1 is 4, to the negative 2 is 16, and to the negative 3 is 64. We can also think of 1/4 to the third as equal to 4 to the negative 1 to the third, which is then going to be again equal to 4 to the negative third, or 1 over 64. Okay, and again, a lot of this will be review for you, I realize, so, but I just want to make sure that everybody's on the same page with all this stuff. Okay. Again, easy to forget here, especially under pressure. This is not y to the fifth, it's y to the sixth, and we could think about it as y times y, y times y, y times y. Y squared to the third power is equal to y to the sixth. X times y squared to the third power is the same as x to the third times y squared to the third is equal to x cubed y to the sixth. Next one we have is x over y cubed is the same as x cubed over y cubed. We could also think of it as x cubed times y to the negative third. Okay, 3xy to the negative 1 to the third. Final answer should have no negative exponents. Okay, so we will say therefore that this is going to end up as 3 to the third times x to the third times y minus 1 to the third is equal to 27x to the third, y to the negative third, but we're not using negative exponents, so we're going to rewrite this as 27x cubed over y cubed. Okay, this one, which would be hard to evaluate on a calculator, but we can rewrite as 2 to the 1195 times 3 to the 1194 over 2 times 3 to the 1193, which then simplifies to 1195 again, 3 to the 1194 over 2 to the 1193 times 3 to the 1193. Here we end up with just 2 squared times 3 to the first, so that's just equal to 12. Okay, difference between negative 3 to the second and negative 3 in parentheses to the second. Okay, order of operations for the first one says the first thing we do is raise 3 to the second is equal to 9. Second thing we do is multiply by -1, and so we get 9 times -1, which is equal to -9. This one, order of operations, says that the first thing we do is we multiply the 3 by negative, so we have -3. Second thing is we take this thing and square it, which gives us -3 times -3 is 9. So in the first case we have -9, second case we have +9. Moving right along. Okay, so under what conditions are these two equal to each other? Let's work it out. So in the first case we have 1 over 4 times x to the -1 plus y to the -1. So we have times 1 over x plus 1 over y, and we're saying that that's equal to 1 over x plus y. Okay, well, in order to do any work inside the parentheses here, we need these to have the same denominator, so we're going to multiply by y over y here, by x over x here, which is going to end up giving us 1/4 times x plus y. I just reversed the order here. This was a y, this was an x up here. So I now have x plus y over xy. And we're saying that if these two are equal to each other, x plus y, then therefore what that means is that the cross products are going to be equal to each other. So let's take one more step. We'll say that x plus y over 4xy is equal to 1 over x plus y, which is to say that x plus y squared is equal to 4xy. And, sorry, running out of room here. So that means that x squared plus 2x plus 2y is equal to 4xy. We subtract 4xy from both sides to get x squared minus 2xy plus y squared. Sorry, there should be a y squared over here. And that's is equal to 0, and we can factor this because it is a perfect square trinomial to get x minus y squared is equal to 0, which is going to be true if and only if x is equal to y. Okay, so you should know these terms here. The radical symbol is this thing here. The root index is here. The radicand is here. And our solution or root is here. So again, this is equivalent to writing 81 to the 1/2 power. As we can see over here, these two are the same. This is the power, this is the root index. So 81 to the 1/4 would be equal to the 4th root of 81. Now, 81 to the 3/4 would be equal to two ways to write it. The 4th root of 81, and then that number cubed, or the 4th root of 81 cubed. Another way of thinking of 81 to the 3/4 is that 81 to the 3/4 is equal to 81 to the 3rd to the 1/4, which is equal to 81 to the 1/4 to the 3rd. So this is commutative here. We can put the 3 first inside the parentheses, then the 1/4, or we can reverse the order there. Okay. So let's take a look at some of these here. Okay, evaluating these, no calculator. Okay, cube root of 27, so this is 27 to the 2/3. And so we could think of this as the cube root of 27 squared, so it would be equal to 3 squared is equal to 9. Cube root of 125 is equal to 5. The 5th root of 32 cubed, so this is the 5th root, and we could think of 32 as 2 to the 5th, and then that quantity squared, or cubed rather, so this could be that this is the same therefore as saying 2 to the 5th, and then that raised to the 3rd, and then that raised to the 1/5, which ends up giving us 2 to the 5 times 3 times 1/5, which is equal to 2 cubed, is equal to 8. Okay, and then again, this is equal to 32 to the 3/5 power. Okay, the 10th root of 1 is just 1. The cube root of -8 is -2. The cube root of 8 squared is we could say it's equal to 8 to the 2/3. And so we could say it's 8 to the 1/3 squared, which would mean that it would be equal to 2 squared is equal to 4. Or we could say it's equal to 8 squared to the 1/3, which is equal to 64 to the 1/3, which is again equal to 4. Okay. Finally, on this page, these we said that we want to do here. So 16 to the -3/4 is the 4th root of 16 raised to the -3rd. So this is going to be 16 to the 1/4 to the -3rd is equal to 2 to the -3rd is equal to 1/8. 27 to the -4/3 is equal to 27 to the 1/3 to the -4 is equal to 3, the cube root of 27, to the -4, which would be equal to 1/3 to the 4th, which would be equal to 1/81. Okay. -125 to the 2/3. The cube root of -125 is -5, so we end up with -5 to the -2nd, and that would be equal to 1/-5 to the 2nd, which would be equal to 1/25. Okay. Simplifying each of these using only integer exponents. And so what that means here is that we are going to be using, 1 second here, we use this, cube root of 8x to the 6th. So we can rewrite this as the cube root of 2 to the 3rd x to the 6th, which is the equivalent of 2 to the 3rd x to the 6th to the 1/3, which is equal to 2x squared. So that worked out very neatly because both the 3 and the 6 here can be divided by 3. Now in this case, we have 2 is the root, 25, which is 5 squared, p squared q to the 4th. It's going to be equal to 5, the square root of 25, times p, the square root of p squared, times q squared, which is the square root of q to the 4th. Okay, 5th root of 32 x to the 10th. Well, we know that this is the same as the 5th root of 2 to the 5th x to the 10th. And again, these are both divisible by 5, so we end up with just 2 to the 1st, or 2, times x squared. Okay, now it gets a little trickier because we have an exponent that's not divisible by the 3 here, and so we want to use only integer exponents, and we're going to end up still with a radical because we're going to say this is the equivalent of the cube root of 8x cubed times the cube root of x. This we can simplify to be 2x, and then we still have the cube root of x here. Over here, we have that the square root of 32, so we have the square root of 2 to the 5th p cubed. We could break this into the square root of 2 to the 4th p squared times the square root of 2p, and this simplifies to 2 to the squared, or 4p, times the square root of 2p. Okay. Over here then, cube root of 16 x to the 5th is the same as the cube root of 2 to the 4th x to the 5th, which we can break into cube root of 2 cubed x cubed times the cube root of 2 to the first times x squared. So we end up with the simplified version of this is 2x times the cube root of 2x squared. Okay, then it asked us to simplify 3D through 3f using fractional exponents, no radicals. Okay, so in the first case we could write this as 8 to x to the fourth to the 1/3, and that's going to end up as 8 to the 1/3 times x to the fourth to the 1/3 is equal to 8 to the 1/3 is 2 times x to the 4/3. Over here we have 32 p cubed to the 1/2. So we're going to get 2 to the 5th times p cubed to the 1/2. And that's going to be equal to 2 to the 5/2 times p to the 3/2. And then finally we have 16 x to the 5th to the 1/3, and that's going to be equal to 2 to the 4th x to the 5th to the 1/3 is equal to 2 to the 4/3 times x to the 5/3. There's other ways to write this, but these certainly work. We have just a number raised to a power times an unknown or variable raised to a power. Okay, all done.